Hey guys, welcome back. Fred here. We're just going to finish up this virtual work question. I know it's a little bit long, but we're going to do our best here to just try and not make it as long as possible for you. And I'm going to show you exactly what to do in this next part of the question. So we're left with this. I hope you can see that. We're left with the table there. And what we're aiming to do at this part of the question is to plug these values that we need into our formula here. So I'm going to rewrite the formula. So we have theta at C. So we have 1 theta. Okay, that is equal to, as we discussed before, we have sigma, so summation of the integration of mvm over ei dx. Okay, and now, you know, I know it seemed a little bit complicated when we were breaking it up into different parts. I know you could just take it from A and you could take 2 integrations, but during the midterm, okay, if you have a really messy integral in this part of the equation, you're more likely, and your limits aren't from starting from 0. If you had from, for example, 0 to 6 and 6 to 12, okay, your bottom integral is not going to be 0. This is always what you kind of are aiming for in this question. If your bottom integral is not 0, what you're going to have, that second term of the integral, you know, you have the top minus the bottom. The bottom will also be something. So you're going to have this very kind of long, messy formula that you're going to have to do by hand. And that's where, even personally, I made some mistakes. So I just wanted to share that with you. So let's go ahead and let's take a look, and you're going to see how easy this is now that we pick the easiest coordinates to do the virtual work method from. So what does this mean? This formula mean? Well, we have the virtual moment times the moment divided by EI, which is constant, over times dx. Since EI is constant for all of these, we'll just take EI out at the start. Okay, so we have 1 over EI. We're going to multiply the whole thing by that. And let's go with the first segment. So we have mvm dx, the integration of mvm. So we have 40x times 0, okay, dx, that's just going to be 0, right? What else do we have? We have plus the integration of 480 times 0, and guess what? That's also 0, okay? So as you can see, the importance of selecting the correct origin. Otherwise, we'd have a huge integration that we'd always make a mistake on. Finally, we have plus, and now this term is not going to cancel out. We have the integration of mv, we'll do m, so 38.5x minus 1.5x squared over 2. That's going to be multiplied by x over 30 dx. And the, sorry, I didn't fill in the limits here, but those don't really matter because those are 0. And the limits are going to always be from our limits that we specified here, so 0 to 30. So if we go ahead and work out that integration there, you know, it just takes some kind of careful multiplication. Make sure you expand properly. So you're going to have 38.5x squared over 30 minus, you know, 1.5x cubed over 60. Okay, so go ahead, do that, integrate it. I'm not going to, you know, do it out because that's very simple. You should know how to do that at this point, and this video is long enough. So I'm going to give you the final answer, okay? So if you integrate, these are both 0. Okay, if you go ahead and integrate this, we are going to get an answer of 6,487.5. The units are kip squared feet cubed over EI. Okay, so what does that mean? Well, that just means that we have to plug in our value of EI. We have is 29,000 kips per square inch and 2,500 inches to the fourth. We can go ahead and convert this to inches. And how we do that is we're just going to multiply the top of the equation by 12 squared. So it's good to know these units just so you know how to do that. So let's write out this step because, okay, and that's going to be multiplied by 12 squared. That's going to convert us to inches. And we are just going to plug this in here times 2,500. And if we just go ahead and put that in our calculator, we are going to get a rotation of 0.01289 radian. The rotation at C. Okay, and let's specify the direction. We don't want to make a mistake with that. Very good. So what that means is it's clockwise. Okay, and the answer that you get here, if it's positive or negative, corresponds to the virtual system that you assumed here. Okay, so that's just a sign convention. Cool. So that's the rotation at C. You know, it's not that difficult of a problem, but it's a finicky problem. So you have to make sure that all your calculations, everything is really spot on. You're not making stupid mistakes. Be careful with the origins, you know, and the limits that you choose. Try and make all of these 0. Thanks for watching, guys. Like and subscribe if you enjoyed the video.